and welcome to this Java code along with me, Alex Hansal from Black Sheep IT Consulting, and with a lot of very, very deprecated Java that you hopefully won't notice. So a bit rusty on the Java side, but I was so inspired by the latest new feature in Siebel 22.10. But check out the videos in the description, where Oracle built a connector business service, a Java business service, to actually connect to OCI using the OCI API to identify PII, personally identifiable information, in text for service requests. They added this use case, and also to transcribe a WAV file, a audio file that is an attachment in service request, and transcribe the text using the AI services of Oracle Cloud. Now, here I am in the API documentation for Oracle Cloud Infrastructure, and let's start on the top, so where Oracle has described, well, what must be over 100 APIs, including the Vision API. So this is an AI service which can identify objects and images and analyze documents and convert them into text and all that stuff. There's also the Speech API, which is used by the new standard business service, so creating a transcription job for those attachments, for example. And there's the Language API, which includes such, well, gems as detect the dominant language in a text, detect entities in a text, detect key phrases, detect sentiment in a text, and classify text in both batch and synchronous operations. So that API is well documented, and do check out the videos or trainings on the OCI integration in 22.10 or higher. Today we are going to try, and successfully so, use the OCI SDK, the Java SDK, to create a Java business service in Siebel that can use, well, theoretically any of these APIs can make the calls, but my example is using the Vision API, since that is not supported as it seems out of the box in the 22.10 version, at least. So first of all, you have to start somewhere, so you have to get the SDK. So you can download that from the Oracle page, and I've downloaded it. It's a zip file, basically, the OCI Java SDK. Take the current version, and I've opened the zip file here, so you see there's all the libraries, and, well, you can grab that jar file here, and that has all the compiled Java. It's quite a bunch, so because there are, well, hundreds of APIs there, and that jar file, of course, has to go onto the internal application container of Siebel. So let's check that out. So here's my Siebel installation, MDE home folder, application container internal, web apps, Siebel, webinf, and lib. And this is where the jar libraries go. So you can see I copied over the OCI SDK and also other third-party jar files that are included with the SDK in the third-party folder here. So I didn't copy all of them. I just compiled my code and it kept complaining, and then I identified the jar file and added them. But I ended up with quite a lot of third-party jar files here. So which is fine. You will need them or not, depending on your use case. But I found these to be like the core OCI third-party files that are used at least when I connect to the AI services. Okay, so you have the SDK and put the jar files in the correct folder on the Siebel application container internal. And then taking quite a slow approach here, not using any IDE or so, just created a JBS folder, just any folder name. And well, I put the OCI jar file there. Also needed that one, the Guava file from Google, because it kept complaining, so I added it. And then I started writing out my Java class code for what I call the BCRM OCI adapter class. The rest you see here is the result of compiling it. So here's the code itself. So defining my package here, and it's a Siebel Business Service implementation, so Java Business Service. So you must import the Siebel property set and Siebel Business Service exception. And of course, in your class path, you must have the Siebel jar files as well. And then, well, along the way, I needed to import all this stuff here from Java, util, IO, and math. And I also, thanks to the examples from the SDK, I was able to define which import I need from the Oracle SDK, which is under COM Oracle BMC. Not sure what BMC means here. Is it really deep BMC, the company? Or yeah, maybe if you know that, write a comment. So here's the class declaration. That's the typical Java Business Service class declaration. So you have to write, your class must extend the Siebel Business Service class and throw a Siebel Business Service exception. Must have one method called doInvoke method, and which takes the method name, very similar to a business service in Siebel eScript. It takes an input property set and an output property set. And then you can basically do a switch or if on the method name. I only have one generic method, invoke OCI. And well, being inspired by the standard business service, I'm reading an input property called context, which I use to identify what do we actually want to invoke. Then the SDK, it's very well documented, can be used with a configuration file and a private key, because you need to connect safely to the cloud. So I'm passing the configuration file path here, and I'm passing the name of a profile in said configuration file, setting some defaults here. And let's take a look at that file. So here it is. It can have any name. OCI config is the name that Oracle choose for the standard. So you basically need only one file. And you can have multiple sections in there. So default is, well, the default section. And these details, check out the training videos, you get from your OCI user management. So you get the configuration file details from there, which includes the user, OCID, the fingerprint, the tenancy, OCID, the region. And you also download a key file there, private key file. And you must place this private key file in a folder where you can reach it. Compartment ID is optional, but I added it here. You can add any parameter that you like in this file and then use the SDK, well, the API to read it. So here with the file reader, the config file reader class, there's a get config file method. So you pass the name of the file path and the profile. It will read those. The config object will then have those parameters. You can call a function to get the parameters and the values. And then you use that configuration object to create an authentication provider. And that authentication provider is used whenever you connect to OCI. So again, that's SDK usage. Basically, those two files accomplish the authentication magic. And of course, including the configuration file that you need to put together, and the private key you need to put in a correct folder, and the root certification authority certificate for Oracle Cloud must be in the trust store of your Tomcat. So here's my dispatch section where I have basically implemented two context use cases. Identity regions, get a list of regions. That was a first test based on an Oracle example. And then I created vision.analyzeImage. But you can see that just dispatched to a private function here and pass the config object, the provider, and the output property set, or in case of AnalyzeImage, the base64 image data string. Okay, so because we're focusing on the AnalyzeImage, let's go down to that function. So here we go. So it gets the config file, gets the provider, gets the base64 image data, and it gets the output property set. So here's how you create a client for using the OCI SDK. You use the correct class like AI Service Vision Client. So there's one client for each of these 100 plus APIs, and you pass in that provider. That will establish the connection. For the functionality, I also need that compartment ID string. So you see you can get something from the configuration using a simple function. Then because we're using base64 here, so the image must be passed as a base64 encoded string, we have to decode it into a byte array. And using some standard Java here, which I found on the internet, thanks Google. The following is taken right from the documentation. So there is a builder principle. So you have to pass in data to the call. Like in a REST call, you have to populate the body or so. But it will be probably a REST call done, but we are creating the input using builder, the builder principle. So there's an analyze image details builder. So we're adding the features, we're adding the image, the data, the image data, and the compartment ID. And then we pass these image details to the request builder. Also with a fake request ID, this is going to be a prefix. And here's the call to the actual API. So we're expecting an analyze image response, calling the analyze image client function with the analyze image request object. And then we can, take care of the result. There's a try catch block, so if anything goes wrong, we get an error message. And now we get the results from the response object. And according to documentation, there's labels in there. So a list of labels. And so let's get those labels. There's a nice getter function. Create a property set to hold them. Type labels, and then iterate the labels list. Setting properties as we go with the label name. So that's be what the image recognition has recognized, like a tree or car or a person. So it will say like, this is a tree. And the second value I'm getting is the confidence level that the AI service puts out, like it's 99% confident that this is a person. And so you will have these key value pairs in the classic Siebel property set, which we add to the output property set. So this was a fast walkthrough through very primitive example code, but it accomplishes the connectivity to OCI, a secure connection, and it calls an documented API, and it parses the result and populates the output property set. Very much like probably, you can't see the code, the standard OCI web service from Oracle does. So let's spend a bit with the documentation, how to read it. So here's the analyze image part of the Vision API. So the analyze image and analyze image result reference. So this is analyze image means the request. And in the request you see, well, first and foremost, a Java SDK example, where I copied the stuff here. And here's the image details builder. I modified this a little bit, but basically that's the code you saw in my example. So I use this example code, and then you can also use the reference for analyze image details. So what you must pass in the request body, and you see you must have an image feature object, it's required, and you must have an image object, it's required as well. So this is an array of image features. And depending on what you do, you can do three things with the Vision API. We're doing the image classification. We're implementing the image classification feature in the code. You should see that here. Yeah. And remember, it's an array of features. So we have a new array list. And here's the builder builds basically one entry in the array. This entry needs an image, which must be built. So that's an image object. So if we go back up one level, you see the image details object. You see must have a source, which by default is inline. And if you use inline, then it's base 64, but must be a byte array. So it must be converted. And it's not a string byte array. Or you can use the Oracle object storage. You can upload the image to a bucket and then tell the API where it should download the one or many images. So here you see must have a source, which inline is the default, and data, which is, well, the raw base 64 data. So this is what I'm doing here, creating that image object with data, with the byte array, and, well, the compartment ID is part of the image details, where the job will run. So this helped a lot in identifying the correct classes. There's no example for the Vision API that I've found other than this one, but it helped me do the job and create that prototype. So you now want to see that in action, won't you? So here's an image I grabbed from the internet, obviously a tree. And that image is a JPEG image. I also uploaded it as an attachment, but currently the implementation is not able to work with attachments, so mind that. But basically what I have is an image file. So here's the tree JPEG file. And you need base 64, so I use, well, there are plenty of base 64 converter pages on the internet. I just pick this one. So choosing the file and encoding it. So that works fine. I can copy the base 64 code. And now let's call the business service. And I'm using DevPops here. So we have that service runner in DevPops, which allows me to use presets as well. Quite clever. And so what I'm calling is the business service. I need to show you the business service, right? So that's here in Siebel Tools. So you create a business service basically copying the standard CSS Java business service. Any business service with that class, really. And you can add method definitions if you want to. I didn't bother, not yet. But you have to add a user property, which is the class. So when you compile your code into a class, and then you have to make it into a jar file, that will be the class path it uses. That's the package name and class name. So this user property is the definition of a Java Business Service, and that compiled jar file, or so when you compile the code, get the class file, you can create a jar file, and that jar file needs to go into that very webinf lib folder on the internal application container. So here it is, copied here. Of course, you need to deliver that business service, so you can now call it from the Siebel application. So I'm doing this here from the service runner. You can do it from Business Service Simulator, invoking the invoke OCI method. And now let's paste that image data base64. It's a property, could use value if you wanted, the context, the default profile, and the path to my OCI config file. Okay, let's run this. So it uploads, well, it calls the API and comes back. Well, the first call is always pretty slow. Let's run it again. So the second call was decent, 1.2 seconds. And we can see that it has identified with 98% confidence A3, 96% confidence that's vegetation, and well, 94% it's a branch or a twig, with 96% or a trunk. So it identified several pieces of, well, plants in that image. So there you have it. Can be quite useful to, if you have an OCI tenancy, to use the OCI API for all kinds of services, including the AI services such as language, speech, or even vision with that custom implementation here. Thanks for watching. Take care and bye-bye.